All right, so hopefully you've had a chance to peruse this higher order derivatives. It's actually pretty intuitive. Once you see it, you'll be like, oh, okay, I get that pattern. It's pretty clear. All right, now let's look at some special cases in motion problems. So some special, they're not really special cases, maybe special considerations for motion. Maybe some just notes or observations. S prime, if S prime of t equals 0, the object is instantaneously at rest. So famously, one place that this happens is if you throw an object straight up in the air and then it returns and falls, right on you. At that one instant at the top of the trajectory, the object is not moving for a period of time of 0 seconds. So the object is moving up, stops, and comes back, and the amount of time that that object hovers motionless in air is 0 seconds, but a crucial part of the trajectory. If S prime of t is greater than 0, then that means that the object is moving to the right or up, right, depending on the context of the problem. By the way, I'm using S for position now. A lot of physics people do that. For some reason they use S for displacement. I don't know why, they just do that. So S of t, X of t, Y of t, they're all ways to write position, all right? So assuming S of t is position here. That's just a common variable to use. And then, so if S prime of t is negative, then that means we're moving to the left or down. So a lot of times AP question, like a favorite AP question would be, give you some equation for motion and say, over what interval is the object moving to the left? So you would just find S prime, set it less than 0, and then solve the inequality you get for t. That's how you would determine if when an object's moving left or right. All right, so another important thing is that the object changes direction. So they love to ask about objects changing direction, and it's an important question, okay? So object changes direction when S prime of t changes sign, all right? So if you're moving right, your velocity is positive. If you're moving left, your velocity is negative. So if you're going to change direction from moving to the right to moving to the left, your velocity has to change from positive to negative. Likewise, if you're moving up and then you're moving down, the point where you change direction is where the S prime changes from positive, we're going up, to negative, we're going down. Okay, so that's basically just follows directly from this. Now what follows, by the way, from the intermediate value theorem is that the only way that S prime can change from being negative to being positive or from being positive to negative is by passing through 0. All right? That is the intermediate value theorem. That's one reason we looked at that. So that's important because it means if we want to know when S prime changes sign, it has to be the case that S prime of t equals 0. So if we're looking for a point where an object changes direction, we're going to start by solving S prime of t equals 0. Now a trick is that S prime of t could equal 0 without S prime of t changing sign. So S prime of t could do, for example, this. S prime of t is positive, then it's 0, then it stays positive, right? That's a graph of S prime. So, but understand that since S prime is positive the whole time, the object is moving up the entire time. So a graph of S, rather than S prime, a graph of the moving object, the object is moving up very fast. All right, so let's put an arbitrary starting point. The object is moving up very fast, but slowing down at t equals 0, or t equals whatever this is, right? Whatever, let's call it t1 or whatever, right? At t1, the object stops slowing down, but does not change direction. But it stops slowing down and then starts speeding up again. So this is what S is doing while S prime is doing this. So this is an object that is going up very fast, going up slower, 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 stops, and then continues to go up, and then goes up faster and faster. So the object starts out going up fast, slowing down, slowing down, slowing down, stops for a minute, well, for 0 time, and then continues going up again and then goes up faster and faster again. So like if you neglect the time axis, the thing is going whoosh, whoosh, like that. Yeah. Okay. Anyway, it's late. So s prime of t has to be 0 in order for an object to change direction. So this is important for a ballistic trajectory. So when we talk about things going up, you shoot something up and then let it fall back down. That's a really standard application of this. So ballistic trajectory. All right, so a couple of vocabulary words here. So ballistic means we throw something. It's really from the word ball, which actually comes from Latin. Ball, so bala is Spanish for bullet, right? Bullet probably comes from the same, right? We talk about ballistic missile means something you throw, okay? So ballistic means thrown. Trajectory means a path that something follows. So ballistic trajectory, the path that something follows when you throw it. Okay, so in a ballistic trajectory, generally speaking, you want to throw something up and then it's going to come back down. Typically we're like throwing, I don't know, water balloons or something, whatever we're throwing. A lot of this, of course, came from military science, and like the big question was, if I fire artillery, where is that artillery shell going to land? Of course, if you have a missile or a rocket, you have a much more complex equation, because the trajectory is no longer ballistic because it has its own power. It's not just under gravity. Of course, ballistic trajectories are also much more complicated because when an object is spinning and it creates air resistance, it changes all the equations. So you can do there's a lot of science behind throwing things and getting them to land where you want them, whether you're firing a probe to Mars or a rocket launcher at someone that you want to blow up. It's going to follow a ballistic trajectory, and you would like equations that describe how that happens. All right, so that's what we're going to start looking at next, is how these equations work for ballistic trajectory.